Good morning and good afternoon, everyone. Before we begin today's clinical webinar, I would like to take a few minutes to briefly introduce Ray. Ray was founded in 2004 and has grown into a global leader in digital dentistry. Since developing the world's first combined CT with a flat panel detector, we have continuously expanded our technologies and solutions for dental professionals worldwide. Today, Ray operates 20 offices and 15 subsidiaries around the world, serving customers in more than 90 countries. A significant milestone in our journey came in 2010 when Ray became a subsidiary of Samsung Electronics. During this period, we strengthened our technology, quality standards, and development capabilities. In 2015, Ray became an independent company. Many talented engineers from Samsung Electronics joined Ray, bringing valuable expertise and experience. Combined with the quality standards and development process established during our time as Samsung subsidiary, this helped us further improve the quality, reliability, and competitiveness of our product. Building on this strong foundation, Ray continues to drive innovation through its 5D imaging solution, integrating advanced digital technologies into a seamless clinical workflow. At Ray, we provide a complete digital workflow under the concept of scan, design, and make. In the scan stage, we offer advanced imaging solutions, including CBC systems, intraoral scanner, and our unique 3D facial scanning technology, RayFace. In the design stage, our software solutions support digital treatment, planning, design, and simulation. In the make stage, we complete the workflow with the milling machines and 3D printer solutions, enabling the clinics and laboratories to deliver efficient and predictable outcomes. By integrating imaging, AI, and manufacturing technologies into one ecosystem, Ray is helping shape the future of digital dentistry. Thank you for your attention. And now it's my great pleasure to introduce today's speaker, Dr. Jung-Jo Kim. Please join me in welcoming Dr. Kim for today's clinical webinar. Thank you and enjoy the session.
Good morning, everyone. My name is Jae Kim. I'm a KOL of the Ray company. So here is the Korea. So now 3 p.m. So fortunately, I did not adapt the Korean time because I spent over 1 month in Europe. So it seems like a morning. So anyway, good morning. So today I'm going to introduce Ray company's 5Ds. So today's my presentation consists of the two parts. As a first part, based upon a clinical point of view, I'm going to explain the background of the developings. And as a second part, I'm going to show the live demonstration about the 5D softwares. So as a first step, I try to understand the background of why we developed the 5D softwares. So can you hear me? Is it okay? Yeah. So as a dentist, actually our main job is we have to improve the patient quality of lives. So I'm quite good at this kind of the work. But when I try to this kind of the things, I always pair into the uncertainty situations. So one of the representative uncertainty situation is like this. When you see the only very small view, like a single tooth or only tooth part or only gum part, some things, we cannot understand the full situation of the patient. So nowadays, dental treatment trend is a little bit changing. So based upon a patient pace or patient smile, patient emotion, we catch some problems. So as you can see in these pictures, when you see the patient smile, it means the pace. You can easily notice this patient has a very unfavorable smiles. So at this moment, use a 3D image like a Rayscan scanner, we can simulate the final goal like this. So through this image, we can give the consultation, and through this image, we can discuss with our colleague. Colleague means the hygienist or lab technicians. So in this case, clinically, we need aesthetic clinical crown lengthenings. Frankly say, the huge area of the aesthetic crown lengthening is not easy. Like a implant dentistry, yes, we use some kinds of the device. That is the clinical lengthening guide. So based upon a 3D image, we can print out the crown lengthening guide. And based upon this guide, we can cut the gingival very symmetrically. And then based upon this crown lengthening guide margins, 3 millimeter below, that is the ideal crystal bone levels. So through this simple equipment, we can cut the gingiva, we can arrange the bone, and then we can give the very nice clinical crown lengthening procedures. And right after finishing the crown lengthening surgery, when I compare two images, it means the after surgery and before surgery images, not only the patient, but also the every dentist or hygienist can easily catch this therapist effect. And this is the small things. So for the crown ratios, I give the small tooth movement, and then we can put in a final restorations. So the one of the best keyword, important keyword, how we can solve the uncertainty situations, the keyword is the information. But when you talk about the information, individual based upon an individualistic characteristics, information is more important things. That's why nowadays a lot of the dentists try to understand based upon a patient face type, face skeletal type, or based upon a smile, they can try to make a treatment plans. So this is the workflow. So user 3D image, we can make the diagnosis, and user 3D image, we can make the treatment plan. Treatment plan means once after you see the final goal, you can easily make the treatment plans. And then through some kind of the device, we can do the real practices. So maybe contemporary dentistry's keyword is the top-down treatment concepts. Someone said it's the same meaning. Prosthetic-driven concept, face-driven concept, smile-driven concepts. Everything is the same, but terminology is a little bit different. But basically, this concept is based on see the final goal first, and based upon a final goal, we have to make the treatment plan and do the practice. So in an analog era, for this kind of the things, we have to collect a lot of the clinical data. It means the stone model, DSLR cameras pictures, and the radiographic pictures. And through the DSLR, we capture the patient face, not only the front, but also the lateral or 45-degree somethings. But when you talk about this kind of the data, every data shows the different properties and different dimensions. So after collecting the data based upon a clinician's experience or knowledges, they make us some 3D image their own brains. It is not easy things. But anyway, every dentist make some kind of the vague 3D image in their brain, and based upon that 3D image, they do the practice. We called this ability as a spatial cognitions. So solving these problems, the best way is use 3Ds. For example, when you see this chair and when you see this sculpture, yes. If we capture the image, 3D object change into the 2Ds. But when you enter into the real 3D images, we got a very different information from that ones. Some called this is the illusion, some things. I don't care about that. It means if you want to try to get a qualified information, instead of the 2D, we have to use the 3D images. So when you see the yes sculptures, if you change your position, you can see the no or on somethings. So we have to change our attitude from the mental 3D to the object 3D. So how we can make the object 3D? That is the progress. But Lay company has a very nice 3D CBCT machines. And they also have an intraoral scanner. And they have a very special equipment, the one-shot face scanners. So if we combine these three kinds of the digital data in one coordination, we're going to make the fully digitalized the patient like this video. So anytime we can access and anytime we can open this data, and through this data and through this our computer, we can analyze and we can catch the problems, and based upon that, we can make our own treatment plans. So for example, this is the clinical case. So when you see the photographs and when you see the panorama view, even though this patient loses a lot of the tooth, when you see the panorama view, the remaining bone height and bone quality is very nice. So maybe it looks easy, but when we use the 3D images, we can get a more precise and qualified informations. So after to a CBCT and after merge the STL files, and when you define the center of the face, you can easily recognize this patient problems. Left and right shows the too much deviations. So when you put in a diagnostic exam means the future goals. In this status, we cannot make the final restoration. So in this case, instead of the bone regeneration, we have to change the gingival lines. So solving these problems, cut the gingiva and cut the bone. After that, we have to place the implant. This is the best merit of when we use a 3D images in our practices. And when you see the lower, the future goal and the present dentition shows the very huge amount of the differentiations. So in this case, I can make this kind of the treatment plan. Tooth should be moved like this. And for the immediate loadings, intentionally, I'm going to extract it. This is very easy things and very intuitive things. And based upon this image, I give the consultation. And after that, based upon a final restoration image, I place a lot of the implant virtually like that. And then place the implant and cut up the bone and put in an immediate restoration. As you can see in these pictures, based upon that procedures, I get a favorable height of the tooth abutment, and then we put in a restoration. Also, we can recover the patient's smiles. So easily say, yes, panorama view is very, very useful diagnostic images, but kind of these things. When you see the plan map, we can easily recognize the structures, but this is not the reals. So for the reals, we have the globe maps because Earth is the spheres, right? So when you use the globe maps, it gives a more high quality information. So for solving these kinds of the tracings, we need more high technologies. It means when you use the 3D image, it is very nice. But when we make that imagination into the realities, we have to use some special devices. But nowadays, use a CAD-CAM, we can solve that problem very easily. we call that is the cost. So for example, in this case, I want to try to make the recover the one tooth. So digitalize the model means use an intraoral scanner, scan it, and draw the wax off, means to see the final course, and merge this STL file to the CBCT. And based on that, based on a 3D image, I can place the implant virtually like this. And after that, for this result, I designed the drill guide. And based upon the drill guide, I gently drill the bone. And after that, place the implant. Of course, through this device, I can control the implant depth and internal hex position, same as the virtual diagnosis. And then nowadays, if operation site is very favorable for the immediate loadings, yes, before the surgery, we can make the provisional restoration like this. So-called, this is the true immediate loadings. And after that, we can make the restoration. And when I follow up this patient during the 5 years, it shows the very good signs. That's why I use the 3D diagnosis. Not only the single tooth, but also the full mouth reconstruction, yes, make the virtual patients and design the future occlusions. And then based on that, I can place the implant virtually like this. And after that, I have to make this imagination into the reality. For that, based on a 3D image, I put out some data, and based on that, drawing the guide and the use of 3D printer or milling machines, we can make the devices. So through this implant guide, I can place the implant more precisely. So anchor the frame and drill the bone. And after that, place the implants. As a result, we can obtain this kind of the very nice implant arrangement. It means the buccolingually, apicocoronally, this implant position is perfectly almost the same as my virtual planings. Right after, I can do the lower surgery, same manners. So arrange the bone, place the implant, and then put in a temporary restorations. This is very nice for the patient because we can quickly recover the patient in setting and functions. So 10 days later, patients finally can chew the meals and improve the aesthetics, and then just change the material into the final restorations. Yes. So basically why we have to use the 3D diagnosis and 3D images means through this one, we can do the very well arranged the planned approaches. This is very important keyword in the modern dentistry. So briefly say, nowadays contemporary digital dentistry workflow, we have a 3 kinds of the CAD. The first CAD means computer-aided 3D diagnosis. So for this 3D diagnosis, we need a CBCT, we need an intraoral scanner. Of course, if you have a PACE scanner, it's much better. And through the CAD, through the 3D diagnosis, and based upon our willings, use CAD programs, we can design it and we can manufacture it. And after that, through that devices, we can make the computer-aided dentistry. So this is the modern dentistry's workflow. And please remember the 3 CAD meanings. So this quote is my clinical theme, is spoken by the Da Vinci. And we need a rudder and compass. Yes, obviously, the CBCT is the starting point and the gateway of the 3D diagnosis. So, but unfortunately, CBCT, every CBCT, include the lay CBCT, has a critical disadvantages. So, as you can see in these pictures, this patient wear a lot of the prosthetics and receive the implant therapies. It means this kind of the heterogenic material shows the scatterings. So every dental CBCT has this kind of the limitation. In natural dentition, it doesn't matter. But if patient wear a lot of the scattering factors, it shows this kind of the ugly images. Why we have to use the CBCT? Yes, we have to understand the structures. But when you see this image, if you try to remove the scatterings, yes, normal bone structure also is gone. It means through this image, we cannot easily interpret the patient's 3D structures. So as a first step, we want to try to this kind of the scatterings. So we made a new paradigm in a CBCT image. Academically, the CBCT called as the COM-beam computer tomograph. So nowadays, lay company make a new terminology. Instead of the COM-beam computer tomograph, CB means ClearBone and computer tomograph. It means even though patient shows the very difficult situation, it means that have a lot of the scattering factors at the time, we can clearly provide these kinds of the clear structures. So user AI and user segmentation, we can provide the very clear 3D structure images. Basically, technically, 5D is user CBCT segmentations. Easily say CBCT segmentation meaning is die compile change into the STL files. So after scanning the patient face, artificial intelligence automatically reconstructed this kind of every anatomical structure change into the STL files. And after that, we can fill in the voxel inside. Through that, we can provide this kind of the very clear, very intuitive 3D images. Of course, this is the STL file. It means like a CAD program, we can edit it. So as you can see in this video, you can separate the upper and lower jaw like this. Furthermore, you can move or you can extract every single tooth like this. And use a volume MPI, you can easily access the 3D spaces like this. So it means it is more realistic simulations. So if you try to the immediate implants placements, or if you give some consultation to the patient, use this 5D image, we can give the more kind and more high qualities information to the patient. And for the spatial cognitions, we have 3 kinds of the images. So as I mentioned before, we need a plan map. Plan map means the panorama views. So we don't need the additional scanning for the panorama views. So once after scanning the patient's 3D image, AI reconstructed the panorama view automatically. Of course, we can provide the very clear bone image, 3D images. And we have 3 kinds of the MPI views. So through this one, we can see the inside of the bone. So we have 3 kinds of the dimensions. So based upon that, every dentist and every patient can get easily their situation and they give the information to the patient. So clinically, the meaning of the CBCT segmentation is this. As I mentioned before, CBCT segmentation means die compile change into the STL files. So based upon our clinical knowledge, we can do a lot of things. For example, in young patients, instead of the implant placement, yes, we can do the transplantation. At the time, use a segmented tooth, we can stimulate the transplantations. And then we can design the transplantation guide. And like an implant dentistry, we can do the transplantations. And in this case, this is the endodontic treatment. So this is the calcified canals. So at the time, we need special cognitions. It means we have to know the pathways. But in a calcified canals, we cannot catch that in. But through the 3D image, we can estimate the pathways, and based on that, we can make the endodontic guide like this, and we can negotiate them. Previous case, this is the crown lengthening guide, and through the lengthening guide, we can cut up the gingiva, and we can cut up the bones, and we can give the minimally invasive surgery like this. Not only the intraoral lesions, but also the whole face, we can do this kind of the things. So sinus guide, designed, and also kinetic surgery guide, and we can recover the patient's deformities like this. So CBCT, through the based upon the CBCT segmentation data, we can do a lot of the various things. It's the same as the analog ways, but use the digital technologies, we can do that things more fancy and more effective and more easily things. So this is the why we developed the ClearBone as a first steps. So frankly say, ClearBone is the Lay's first step of the 3D technologies. And from now, we're gonna add a lot of the clinical functions in a 5Ds. But this is good enough for the patient consultations. So this case is my first case when I tried to the Ray 5D viewer in clinical situations. So this patient wanted to improve her aesthetic and the functions. So at the time, I designed the future smiles like that, and I give these images. But sometimes patients want to see the real final restoration images. Don't worry about that. We can print out the mock-up veneers, and you can get in like this, and just give the mirrors. When she shows the mirrors, yes, this is the what I want. It's very easy things. So based upon that, this mock-up veneer images, yes, we have to do the clinical crown lengthenings, vertical dimension, increasing some things. How about this? When you see that this patient, yes, gum line is good, and smile is also good. So she was so disappointed about her tooth shape and colors. So in this moment, I give the mock-ups like this. And fortunately, based upon this patient's skeletal patterns, without the tooth preparation, we can give the number veneers like that. So they have also very nice milling machines, inlet milling machines. So I milled it and attached it. Just in one day, we can change the patient's smile and functions like this. So everything is the 3D diagnosis, and visualize the final form, and based upon that, give the consultation and make the treatment plans, and use the CAD and CAM. We can manufacturing that and do the dentistries. Not only the tooth prosthetics, we can make the denture some things. So this patient loses the tooth during 20 years. So use a late clinical solutions. We can provide the 2-visit dentures. So use a special tray. We call this is a Ray E tray. Use a tray, take an impression, and determine the vertical dimension. And after that, took a face scanning. And also, Levy CBCT has a very special function, this one. Instead of the patient scanning, after took an impression, if you put in an impression tray in a CBCT machine, use a CBCT, we can obtain an STL files. So right after took an impression and determine the vertical dimension, instead of the stone pouring, just put in this impression material and tray into the lay CBCT machine, and through the object scan function, scan it. And if I inverse it, I'm going to obtain a edentulous ridge images and merge it. And after that, design the future smiles and give this information to my lab technician. My lab technician draw the denture images. Also, we can give the dynamic occlusion situation like this. And then use a 3D printer, print out it. So second visit, we can put in the dentures. How about these dentures like this? Even though I retracted the patient cheeks, this both upper and lower denture shows the very nice suction conditions. Even though patient grinding, the suction condition is still shows the very firm conditions. And after that, based upon the denture, we can design the restorations and design the implant position and design the guide, restorations, and do the surgeries. So not only the implant dentistry, of course, mainly a lot of the dentists for the implant dentistry, they purchase the CBCT. But not only the implant dentistry, but also every dentistry field, we can apply to the CBCT and 3D images. So I love this sentence. This is spoken by the Yamani. The Stone Age didn't end because we ran out of the stone. It's exactly same as nowadays situation. I don't want to blame or I don't want to criticize the analog ways. Actually, I was a big fan of the analogs. But when I use the digital technologies in my daily practice, it changed into the more easier and effective somethings. So 3D and the digital technology is much better than the analog images. So this is the will be released soon. So basically, Lake Company has this kind of the schedules. So as a first step, we developed the very clear 3D volume images, so-called ClearBone. And then from now, we're gonna add the clinical functions. So as a first step, it will be released soon. So like this video, after place the implant, use a digital brush, you can draw the areas, and that area will be changed into the guide. It means you make your own guide in 1 hour. And when I printed it, it shows a very nice accuracies. And also, if you have a light pace scanners, yes, this function is inside it. So we will be putting this function in a 5D. So instead of the expensive devices like Acoustigma, Mojo, some things, just use an intraoral scanner or face scanner. If you obtain a 3 kind of the check bites, we can get a jaw simulations like this. And this data automatically go to the third part, means the exocad or 3 shapes. So through this information, your lab technician make the more functional prosthetics. So through this kind of the procedures, as a dentist, I can do the very planned and very well arranged treatment. So this is the why we developed the 5D concepts. So that's why we called it the 5D. 4D means the four-dimensional, and 5D we can see the time factors, means the dynamics and the patient emotions and things. So CT, yes, this is the keyword. And I'm gonna skip here. So this is our future course. So once after make the fully digitalize the patient and the user AI automatically analyze and make the treatment plans. And after that, based upon this image, based upon your willings, we can design some devices, and then we can make the very nice clinical result like things. So this is our latest future course. So 5D is the first footprint of our future histories. So because of the time limitation, we will change the screen, and then I'm gonna live demonstrate the 5D softwares. 바뀌었어요? Yes. This is the 5D softwares. As I mentioned before, this 5D consists of the three parts of the views. The first one is the panorama view. Yes, this is a CBCT-based view, and we provided the three-axis MPI view, and this is the 3D volume images. Yes, a lot of you may be disappointed about this image because it shows a lot of scatterings. When you see the panorama view, yes, of course, this case is the most severe, most serious case in a CBCT image because every dentition is the implants. So in this case, intentionally, I turn up the ClearBones. And if you want to increase the 3D sizes, we have two screen mode. So this is the 5D max mode. At the time, if you want to try to the panorama view, of course, you can load it like this. So this is the conventional city viewings. So as I mentioned before, you can see a lot of the scatterings here. And if you try to decrease the scatterings, of course, same voxel value will also disappear. So we cannot clearly understand the 3D structures. So we made the very special functions. So can you see here, ClearBone? So once after I activated the ClearBone functions, yes, you can see these kinds of the clear 3D images. So once after you activated the ClearBone, it will be changed into the STL files. It looks like a CT files, but basically this is the STL files. Due to the STL files characteristics, yes, we can edit it. So if you want to try to the lower jaw only, yes, we can erase the upper jaw only, we can erase the lower jaw. Of course, if you separately try to see the lower jaws like this. And if you want to extract the tooth, of course, you can extract it. And once after you extracted the tooth, you can see the extraction socket image like this. So this is very good for the consultation and simulations. So for example, in this case, if I try to place the implant here, we need a diagnostic exam. So at the time, instead of the third part CAD programs, we have a diagnostic exam functions. So in this case, we need a Portus, and if I apply it, yes, Portus will be placed, and use a mouse. We can arrange it. This is very simple vector functions. So like this. Through the yellow, you can arrange the scales, and through the blue, you can rotate them. Of course, in this part, we have to check the antagonist. So this will be more sure. And after that, directly we can simulate the implant. So this is the MPI, 3D MPI. So once after activated the 3D MPI, you can control the angulation and you can control the position like this. Of course, use a MPI, 2D MPI, also you can control it. And in this case, as you can see in this video, you can see the huge amount of the bone defect like this. So we have a lot of the implant icons. So if you click the implant icon, automatically one standard implant will be placed. This implant specification is the standard implant. So length is 10, diameter is 4. So through the computer, you can change the implant length and implant diameters like this. So based upon a specification, this number will be changed. So this implant diameter is the 4.8 and length is 8.5. This. And we have a very convenient functions. So instead of this view, we can directly cut off the 3D views. So through this one, you can never lose your spatial cognitions. So instead of the 2D, we provide the 3D MPI views like this. And also you can make the hybrid image. Even though you can see the cross-section views, you can see the resident part of the 3D image like this. This is much better because normal conventional CT view only provide this cross-section views. So you cannot see any kind of the 3D image, but use a hybrid image, you can see the cross-section view. Also, you can see the remnant 3D view like this. Through this image, you can precisely control the implant three-dimensional positions. And we have another special function is the color-coded bone. So through this color, you can easily estimate the bone density. For example, if you see the black colors, that object density is almost the same as the air. And if you see the red color, that is almost the same as the soft tissue. And if you see the gray and yellow color, that is the density is same as the cancellous bone. And if you see the green colors, that is the hard bones. So based upon this intuitive color code, you can easily notice the patient's bone densities. So based upon this color code, when you try to the implant dentistry, yes, we provided a color-coded implant like this. So as I mentioned before, the apical part shows the green and yellow color means even though this patient shows the huge amount of the bone defect, yes, we may obtain an initial stability. And how about here? When you see the inside of the bone defect, it shows the red colors, means this part will be filled with the granulation tissues, right? And also, I'm gonna try to place one more implant here. So based on a diagnostic vector and based upon a bone morphology and bone quantity, I can place the implant like this. So when you see the colors compared to the molar part, it shows the green and yellow colors, means this implant shows the very nice initial stabilities, right? So like this kind of the functions, we can give the very clear consultation to the patient. So this part, surgery will be very easy. And this part, even though it shows the bone defect, this is the intra-bony defect. So we can simultaneously give the bone graft something. So this is very useful tools to the consultation and treatment planning and simulations. And the time is now 45 minutes. And I'm going to show you the natural dentition case. So yes, this is the natural dentition patient. So as you can see in this panorama view, there is no restorations. In this room, some of the dentists joint and also dealers. Yeah. So maybe when our colleague dentist shows this panorama view, yes, you can catch the severe bone resorption situations. So instead of the panorama view, instead of the panorama view, when you see the 3D image, you can clearly notice the bone destruction features like this. So intra-bony defects, interceptor bone defects, percussion involvement, some things. So when you give the consultation to the patients, we have to extract this one. Yes, through this function, you can extract it. And after that, you can clearly see the extraction socket situations. And based on that, you may make your own treatment plans. So in this case, if I cut the bones like this, you can easily see the sinus floors like that. And if you want to see the conventional MPI view, you can make the hybrid images. So here is the sinus floor, and you can easily recognize the remaining bone height. And also, can you see here? This is the haziness. So haziness means it has some sinus lesions like this. So if I place the implant and when I change the colors, so bone contact area shows the yellow and green colors, but when you see the apical part, it shows the red colors. Heresy sinus will be filled with the airs. So as I mentioned before, our 5D shows the air as the black colors. But in this case, implant apex shows the red color, means this is not the air. This is the soft tissue, means this patient has some sinus problems. So based upon that, you can make more precise diagnosis and treatment plans. So we can decrease the length like this. And also we can increase the diameters like that. That's cool, right? And let's go to the lower. When you see the lower jaw, yes, maybe this tooth very hopeless because huge amount of the vertical bone defect at the time we have to extract it. Can you see the red one? This is the root canals. So after extracted the tooth, yes, root canal will be remained. Click one more times. Through this one, we can see the extraction socket images. Can you see the mandibular nerve here? It means this part shows the huge amount of the bone defect, right? So in this site, we cannot do the immediate implant placement, so we have to give the socket preservations. And this is the wisdom tooth, so I'm gonna extract it. And this is the first molar. Yes, this shows the little bit controversy, but percussion involvement and vertical bone defect. So in this case, I'm gonna extract it. And after that, we need a two tooth, wax up tooth. So two wax up applied, and through this one, I can easily arrange the tooth like this. And through the scale, we can arrange the continuous, simultaneous CZ levels. And through the upper jaw, you can catch the tooth relationships. And this tooth shows the molding body. And make the tooth to tooth relationship like this. It's good enough, right? And after that, try to place the implant. So load the implant and place the implant. In the center of the crowns, like this. And use a volume cross sections. You can see the adjacent tooth axis. At the time, we have another special functions. So you can clearly see the mandibular nerve and the adjacent tooth axis. And based on that, you can decide the implant position like this. And you can decide the optimal diameters, 4 point. I love the 4.8. This, and place one more implant here. Yes. And load. So when you see this view, 10 millimeter is very dangerous. So decreasing the length, 8.5. We have a safety zone. And you can decide the diameter immediately, like this, 4.8. And when we activated the color code, can you see the colors? It shows the yellows. But these two implants shows the yellow colors, but meaning is different. It means I already mentioned we have extraction functions. But when you see the slice view, even though I extracted the tooth in the 3D image, when you see the 2D image, still tooth image is remained. It means this is not a real extractions. So we have a real extraction functions. So if I activated the tooth extractions, yes, not only 3D image, but also in a 2D image, we can extract the tooth. As a result, implant color will be changed like this. After extract, there is empty. Empty means the air. So that's why this part changes the black colors. So this is the real situations. So 5D has a, that's why I called it that this is the very high realistic simulations. So maybe a lot of the implant viewers, a lot of the CBCT viewer provided this kind of the color code systems, but they have this kind of the limitation. They have no extraction functions, but we have a real extraction functions like this. So based upon that, you can make your own treatment plan and drilling strategies, some things. Also, you can give the very clear consultation to your patient. So in this case, yes, we have to arrange this very sharp bones, and after place the implant, we have to give it some amount of the socket preservation, bone graft procedures here. But fortunately, simultaneously, we can place the implant and give the bone graft. Through these strategies, we can decrease the treatment times. So this is one of the best benefit why we have to use our 5D viewers, right? And the early morning you joined in our webinar, so I will show you the very secretary functions. So don't let go the screen and just see it, because we have to we have to we need more a little bit development, and we have to receive some approvals for these functions. This is our guided design functions. So this program is the developer version. So only I have the guided design functions. So maybe this is the very severe case, fully dangerous, and I place the numerous implant like that. And after that, we can directly enter into the guided design functions, and then we can do the block out first. And after that, we have a very special brushes. So this is the digital brush. So using this brush, you can design the guide by yourself. This gray area will be covered with the guide. So draw it like this. This part, this area will be changing the guide. And then you can control the guide thickness by yourself, and guide tolerance by yourself, and guide hole tolerance by yourself, like this. And then if you push the buttons, it will be changed into the guide. Let's take a time together. 5 seconds, 10 seconds, 15 seconds, 20 seconds, 25 seconds, 30 seconds, 35, 40, yes. Less than in 1 minute, even though in full arch guide, yes, less than in 1 minute, you can complete the guide design by yourself. And if you have a lay 3D printer, you can directly print out it. So in this case, I'm gonna save YY, and very easy. Sorry. Sorry. Saving folder is different. So let me try again. YY. And you can see the YY files. This is the previous design guide. So not only the single, but also even though the full arches less than 5 minutes, you can design and you can draw and design completely the guide like this. And through our Ray 3D printer, less than in 1 hour, usually it takes the 45 minutes, you can print out the guide. It means even though you try to use the guide, normally conventional ways, you send the data to the center and wait over 1 week. Sometimes in poor edge cases, you have to wait around 1 month something. But through these functions, immediately you can design and you can print out and you can do the surgeries. It will be cool, right? So it will be launched very soon. Because of the time limitation, we have to stop the webinar, right? So thank you for coming, even though in early morning, and sorry for my ugly English. And if you have time, let's meet Europe in autumn seasons. Yes. So thank you for coming, and thank you for your kind attention.